This video is going to look at the idea of momentum. Specifically linear momentum. Now momentum is kind of an idea of how much oomph something carries while it moves. We're going to give it a definition first and then kind of look at some examples. Momentum gets the letter P, obvious reasons, right? It's not an obvious reason. M we've already used for mass. N and O we don't really like to use as variables, so P is the next one. That might be the reason, I'm not quite sure. But momentum is a vector quantity. We give it the letter P and it's equal to a mass times a velocity. It has units. You know how a lot of times in physics we start to get units that get some kind of messy. So mass has units of kilograms and velocity has units of meters per second. Momentum has units of kilogram meters per second. We don't actually make up a new unit for this one at all. Not sure why. It is a vector quantity, so the direction does matter. If I have if I have an animal like this sitting on a skateboard and it's moving along, or if I have the same skateboard and I put, I don't know, some kind of a bug on it, this top one, moving at the same speed, this top one is going to have a lot more momentum than the bottom one. If I have this skateboard and instead of having it moving to the right, I now have it move to the left, now it's going to have momentum with the opposite sign of this guy. So what I need when I do this is to be able to define a direction as positive. If I define to the right as positive, and let's give these some masses, maybe 10 kilograms and 2 meters per second, we'll go half a kilogram, and we'll even leave the same speed. This top one is going to have a momentum of 10 kilograms times 2 meters per second equals 20 kilogram meters per second. It's to the right, so we're going to call that positive. This bottom one is going to have half a kilogram rather, times a negative 2 meters per second because it's to the left, so it's going to have negative 1 kilogram meter per second. That's the idea of momentum. We can look at this in one dimension. That's what this is. So if this is the positive x direction, then we would say this is 20 kilogram meters per second in the x direction. This is negative 1 kilogram meter per second in the x direction. If I have a ball with a mass of, let's say, 1 kilogram, this guy's pretty heavy, and it's moving this way at 3 meters per second, then that's going to have a momentum of, we now need to define a second axis, so let's say upward is positive y. That's going to have a momentum of 1 kilogram times positive 3 meters per second gives me positive 3 kilogram meters per second. But that one is in the y direction. That's it as far as momentum without getting into what to do with it. That's just kind of how to calculate it. We'll leave examples for later.